Alright, what we're looking at today is, this is what we're looking at today. We're looking at segment addition postulate. Basically what this has to do with is taking a line segment and you're going to put it into pieces, and the idea is suggesting that if you add those pieces together, it gives you back the entire thing. That's all. For example, we're looking at, so BM is this line segment here. If you notice, it's split up into 3 pieces. The idea is suggesting that part plus the other part plus the third part, in this case, gives us the whole thing. That's the idea that we will be dealing with. Adding up the parts. So in this case, we have 3 parts. In other cases, you might have 2 parts. Other cases, you might have 4 or 5. But the idea is that if you should add them up together, it's going to give you the whole thing. In this case, we're suggesting that the line segment BX, you don't have to write these examples. I'm going to leave the 2 examples, 1 here and all of that, for your work. So you don't have to write the examples, because what you will do, it will be your notes, right? So basically we're suggesting that BX plus XD plus DM is, if you add them together, you will get from B all the way to N. Take a look. That's what we're saying. These 3 pieces gives the entire distance. Right, James? So in this case, in terms of the numbers, 5 plus 7 plus 10 will give us the entire length. And this is 22, which is BN. That's what we're saying. That's what all of this is about, the idea. Now, what we're going to require of you is that we're going to want you to apply algebra in solving these problems. So if you're okay with your algebra 1, you're good. If you're not okay with algebra 1, you won't be good. So basically, take a look at this. Information that we have here, we have a well-labeled diagram. Sometimes your diagram may not be labeled, which means that you have to label the pieces. For example, BS is 2x minus 3. It's already labeled for you. But it could have been where you got BS to be 2x minus 3, and you would have to put it right here. It could have been where you got SD to be 4x plus 10, and you would have to put it here before you start. Okay? But in this time, right, we already gave it to you as is, so you don't have to do the labeling. But you would have to label where necessary. You got the labels already. So what this is suggesting is that this is BS, 2x minus 3. This is SD, 4x plus 10. And all of this length from B to D is 67 right here. You're seeing it, it's there. Now, how would you find a value for x? You're going to set up the idea. The idea is that BS, which is 2x minus 3, plus SD, which is 4x plus 10. When you add it together, part plus part give the whole thing. But this whole thing is what? Anybody? What's this? 67. That's the whole thing. So at this stage, you're solving a simple algebraic equation where you need to collect your like terms. So let's take another step. When we're collecting our like terms, 2x plus 4x minus 3 plus 10 gives us 67. So that is us collecting our like terms, as you can see here. 2x and 4x comes together, give us what? 6x. Negative 3 plus 10 gives us what? plus 7. And this is equal to 67. We're almost there. In terms of isolating my 6x, I'm going to subtract 7 from both sides. Make sense? So 6x is 60. So to find x, we'll divide both sides by 6. So x is 10. Now, if I know that x is 10, then I'm able to respond to other things. For example, find the length bs. What is the expression for bx right now? So bs is represented by 2x minus 3. But I do know what x is. Therefore, I'm going to write this as 2 times x minus 3. But x, as we found it here, was 10. So basically, 2 times 10, 20, minus 3, and we're again 17 right there. That's what we got. Make sense? Now let's take a look at the other part. They want us to find SD. So let's put our 17 here. SD is represented by 4x plus 10, right? What we're going to do now is that we're going to multiply 4 times x and then we add 10. We do know the value of x is 10. So this gives us 40 plus 10, which is 50. We knew that it was 50 because if you take 17 from 67, which is the whole thing, you realize that you would have gotten the 50 nonetheless, right? Alright, so in this case, we are utilizing the segment addition postulate, setting up an equation and then solve to find x, and from there we could furnish our diagram depending on what they're asking. Let's take a look to this other question here. For this problem here, it's slightly different from what we started with. It says here that A, B, and C are 3 collinear points. Remember, collinear points suggest that they are on the same straight line, such that A, B, and BC are congruent. This is the important thing. A, B, and BC are congruent. We were given that AB is equal to 9x minus 16. BC is given as 6x minus 1. Here it is, we want to find the value for x. Let's draw a diagram to see what's up. So if I was to put a diagram up here, this is my A, this is my C. AB and BC, they're congruent, which suggests that they're what? Equal. So it must be that the point B is a midpoint because whatever I have for my AB will be the same as my BC. Whether or not it look the same, the idea is already there. Congruent means equal. So if I'm going to solve for x, I'm not going to add this and this because they did not give me the total. So I'm going to have to utilize what this word means, equal. So I'm going to say 9x minus 16 is the same as 6x minus 1. Congruence, equality. From this, I could now solve. I want to isolate my x's to bring them on one side. So I'm going to take 6x from the right, which means I have to take 6x from the left. So let us balance this down. 9x minus 6x gives us 3x. There's a minus 16. This is gone. That's a 0. And we're left with negative 1 on that side. We're going to try to isolate the 3x, so I'm going to add 16 to both sides. So 3x is positive 15. Negative 1 plus 16. Then we divide both sides by 3, and here x has a value of 5. Now, if I know that x is 5, then I am able to find the length AB because AB is represented by 9x minus 16. So AB here is 9x minus 16. Remember that we know what x is. X is 5. So right here, I'm going to have 9 times 5 9 5s, 45, minus 16, that's 29. So I found out that, hey, this piece here is 29. Based on that, I would already know what this is. It's 29 too, because they told me that they're congruent. But let us see if it really works. We're going to find the length BC. What is BC? 6x minus 1. So BC is 6x minus 1. 6 times 5 minus 1. Remember that x is 5. And this gives us 30 minus 1, which is 29, as we suspected. The last part of this question says, can you find the length from A to C? I labeled the ideas a lot of times because it let me move faster. So the fact that I labeled 29 and 29, the segment addition postulate will tell me that this piece plus this piece will give me the entire thing. Therefore, all I have to do is to add 29 to 29, and AC is 58. And we're done.